Good morning. This lesson is for our April 1st, Wednesday. We will go over section 5.1. It's about 4-page notes. The first page, we're just checking whether given order pairs satisfy an equation. And then I have a couple examples, word problems, where we will work with linear functions. First using proportionality, and then we will look at some other cases where they have Y-intercepts. All right, so let's get started. The first page, determine which order pairs satisfy the given equation, and what we have is an equation that says x plus 3y equals 13. And then we have 3 different order pairs. Now remember, when you guys get an order pair, that means the first number they give you is the x value, and the second number they give you is the y value. So this is their way of giving you the x and y. What they are asking is, now, will these x and y value really satisfy this equation? Let's check the first one together, okay? So this is the equation that I will plug in my x and y value into. X is, for the first point, x is 4, right? X is 4, so 4 plus, instead of 3y, it's going to turn into 3 times 3 because our y value is 3. And just copy down the other part of the equation. And what we will do is we will simplify this and see if this is true. The left side turns into 4 plus 9. Right side is still just equal to 13. If you add 4 plus 9, then you will really get 13. So if that comes out to be true, when we get to say that 4, 3, this order pair 4, 3, satisfies the equation. Just like that, we have to check the other 2 points. So let's do the other one, the second one. In the second order pair, I'm working with this one right here. The x value is -2, right? And the y value is 5. So I'm going to plug in -2 into x and 5 into y. So that will turn into -2 plus 3 times 5 equals 13. This is -2 plus 3 times 5 will give us 15. And if you add -2 plus 15, you will get 13. So this is, again, a true statement. So we get to say that -2, 5. And, you know, you really don't have to write this sentence every time. But, you know, as long as you know, yes, this one satisfies the equation. Because I think on your homework, you will have to just click on the one that works. So, all right. So both of the one, the first 2 worked. Now let's check the last one. The last one is 0, -3. So that means x is 0 and y is -3. Let's plug that equation, plug those values into our equation. So that will be 0 plus 3 times -3 equals 13. All right, let's check if this is true. This is 0. Well, if you multiply 3 times -3, you will get -9, right? Now, if you do 0 minus 9, you'll get -9. And we know that's not true. So what we get to say is 0, -3 does not satisfy the equation. So out of 3 that I was given, I tested them all, and I found out that only 2 of them satisfy these equation. Now, this is a line, and if you're looking for how many lines satisfy this equation, the answer will be, how many points satisfy this equation, the answer will be like infinitely many. Because if you graph this, let me try to graph this with you real quick. I think later on in this unit, you will be graphing some linear functions. But if you graph this function, we can rewrite this in slope-intercept form. X plus 3y equals 13. Let me move the x to the other side and get 3y equals oopsies, I don't want to change the name of this. -x plus 13. And then you will divide both sides by 3. So the equation will be y equals -1/3 x plus 13 over 3. Now this isn't going to be exactly the nicest graph to graph just because the y-intercept is at 13 over 3. But say that you graph this line, this is going to be a straight line. And the question is, well, how many points are on a straight line? And a line is just infinitely many points, you know, next to each other. So we are going to have infinitely many points that are on this line, but we're just going to be given a couple to test them. Now, I don't think I need to go over all other ones, so maybe I'll just pick one more. Now 2 and 3, I'll stop the video and kind of just work it out and scan and put it on canvas for you. But I will go over the last one because I think you kind of get the idea, because we're just really plugging in the x and y value to see if it comes out to be true. I'll try number 4 just because it looks a little bit different, and then we will move on to the other word problems. All right, let's try this first point. They're saying x is 0 and y is 20 over 3. Let's plug in these values into our equation. So first, x over 2 will turn into 0 over 2, right? Because x is 0. Now, what's next? Now, this one's going to be a little bit messy. We have 3y, 3 times y, and y is 20 over 3. And then that's getting divided by 4, okay? So what I just did was I just replaced this y by my 20 over 3. Everything else stayed the same, right? So that's what happened. And then we're trying to see if that simplifies and turns into just 5. Let's see if that's true, okay? So 0 over 2, that's just going to be 0. But take a look. What happened to this 3? The 3's will just cancel out. And then we have 20 over 4 equals 5. And let's see if this is true. 20 divided by 4 is 5, right? And 0 plus 5 is 5. So therefore, this one, yes, 0, 20 satisfies this equation. So we got that. Let's try a couple more, okay? Let's try the second one. The second one is x equals 20 and y equals 0. Let me zoom out so that I can see the equation. So I need to do x over 20 first. X over 20. That will be 20 over, I'm sorry, not x over 20. X over 2, okay? So that will be 20 over 2 plus, now the hard part, right? I'm just going to stick in 0 right here, okay? So that will be 3 times 0 over 4. What we will try to see is if that comes out to be 5. That was the other side of this equation. So let's simplify this. 20 divided by 2 is 10. And if you take a look at that, 3 times 0 is 0. And anytime you're trying to divide 0 by anything, well, that will really turn into 0. 0 divided by 4 is 0. And I get an equation that looks like this. Well, we know 10 plus 0 is still 10. And 10 does not equal to 5. So what we can say is that 20, 0 does not satisfy the equation. Okay, let's try the very last one. I'm out of room, but maybe I can try to minimize this one a little bit. Yeah, I'll try to do that. Let's see. Go get smaller, because I think you guys can still read that, even though it's a little bit small. Okay, let me try the very last point. On the last point is, what is it? 6, 8 over 3. 6 and 8 over 3. So my x is 6 and my y is 8 over 3. Let's plug in. So x over 2 will turn into 6 over 2. And the second part, I need to plug in 8 over 3 in here. So what I'm doing is I'm really replacing this y by 8 over 3. You do want to write that down. So it's a fraction and a fraction. 3 times 8 over 3 over 4. And we're trying to see if they will simplify into 5. So let's see if this is true. So what happened to the 3's over here? Those 3's will cancel out. So if I simplify this, I will get 6 divided by 2. The first term turns into 3. And then the second term, the second fraction will now become 8 over 4. One more line, right? maybe 2 more lines. 3 plus 8 over 4 is 2. And if I add 3 plus 2, yes, 5 equals 5. So what we got is that this very last point that we just tested also satisfies this equation. So that's what you do if you are given ordered pair. You just have to do all 3 of them separately and see which one or 2 or all 3 of them will give you a true statement, okay? So if you want to try number 2 and 3 on your own, make sure you try to do that, okay? I will work it out, and then I will scan this and put it on Canvas, okay? But what I just kind of did up here, that's not really part of this lesson, so I'll erase that. All right, now let's move on to some of the word problems, the similar problems that you will see on your homework, okay? All right, number 5. Okay, so all the examples that we're about to go over are using proportionality, and some of them are a little bit easier with less information given. But I think starting around like 7 and 8 and 9, things may get a little bit more challenging. But all right, let's go over the rest of these. The distance you drive is proportional to the amount of gas used. Driving 120 miles uses 5 gallons of gas. Now, whenever you get these problems, just highlight the information that will give you miles per gallon, okay? Let's write down the miles per gallon, okay? So you can drive 120 miles using 5 gallons, right? So if you divide 120 by 5, 120 divided by 5 will give you 24. So what we get is that we can drive 24 miles per 1 gallon. Okay, so that's the miles per gallon. And I ask you to find that because this is going to be your slope. Every gallon you have, you get to drive 24 miles. Okay, now let's see. Say that we're going to try to fill out this table first. Say that you have 0 gallon. How much distance can you drive? Well, 0 miles, right? Now the next one, say that you have 5 gallons. Notice that this is the one that they gave us, right? They did say you can drive 120 miles if you have 5 gallons. So this one is just given. If you have 5 gallons, you get to go 120 miles. Now, what if you have 10 gallons? Now, remember, every gallon that you have, you get to drive 24 miles. So what I can do is I can do 10 times 24, and that's going to be 240, okay? Now, if they start at 0, 0, if they start at this point 0, 0, notice we call this direct, what did we call it? Oh, yes, we called it direct variation in a couple of chapters ago, right? And if that's true, it's just going to be proportional. Notice how, if you, 5 times 2 is 10, right? If you double 5, you get 10. So you really double the y values or the output too. 120 times 2 is 240. But, I don't want to keep on using that rule because you are about to see some of the example where that rule doesn't really apply. So I'm going to keep on using our slope, our miles per gallon, to figure out this table. So say that you have 15 gallons. Well, that means for every gallon, I get to travel 24 miles. So 15 times 24 will give us 360. Okay, so, we filled out this table, and then let's give them an equation, a rule that gives the relationship between distance driven. So this is going to be our D, and and gas used. So this is going to be our G. So what's the rule that connects our G to D? Well, remember how we got these distance values. Distance, we got them by simply multiplying by 24, right? So the equation will be D equals 24 times G. That's it. That's the rule. Every input, every G value that we get, we're going to multiply by 24, and that's going to be the distance, the number of miles that we can drive in this problem, okay? So that's it. Number 5 wasn't too bad at all. Now let's go over number 6. Your monthly electric bill is proportional to the number of kilowatt hours, kWh, of energy used at a rate of, now here's the rate, they gave us the rate. And you know what, whenever they give us the rate, saying something per something, this is really them giving us the slope, right? I'm going to write this number down. We were given 5.8 cents per kilowatt hours. Okay, this is the slope they gave us. But you know what? I'm not going to use 5.8 for my slope because, look, the cost, it's going to be in dollars. So if I use 5.8, it's going to sound like we're getting charged $5.80 per kilowatt hour. So we don't want to use 5.8. Write this in dollars. So 5.8 cents is how many dollars? That's going to be 0.058 $, right? So we can do that. We need to first convert that into the dollar amount, and all I did was I simply divided by 100, right? Divided by 100. Because I've seen students missing this problem because they were just using 5.8. Not that you were doing the wrong thing, but you just forgot to convert this into a dollar amount. So this is our slope now. This is our slope. Okay. So let's go ahead and try to fill out this table. If you use zero energy, then we better pay $0, right? But you know what? That's not exactly going to be true because sometimes you still have to pay some kind of fee, right? But those cases we'll look at in different examples like 7, 8, and 9. But for this one, we're just going to think simple. If you use zero energy, then you should get charged $0. Now, what if you use 400 kilowatt hours? Now, what do? We multiply this by 0.058, okay? Because every 1 kilowatt hour, you are going to be charged 5.8 cents. So how much will be the electric bill if you use 400 kilowatt hour? Let me multiply that on my calculator, and I got $23.20. Okay, let's keep going. What if you use 800? Now, we can simply double the answer from above, or I'm just going to keep on using my slope because I want to be able to use that when I write a general equation on the second part. If you multiply, you will get 46.4. $46.40. And that's right, because if you double 400, then you will get 800. If you double 23.2 times 2, then you will get 46.4. So this is working out great because this is direct proportional, direct variation. The very last one, let's multiply 1,200 by 0.058. How much will be the energy bill? Let's see. That's going to be $69.60. Now, if you multiply 23.20 by 3, you will get that number too, right? 23.2 times 3 is 69.6 because 400 times 3 is 1,200. Now, anyways, but keep on using the slope because in chapter 5, we will be using slope and Y-intercept. So I know you're more comfortable with using direct proportion. Hold on. But I do want you to start using slope a little more often, okay? All right, let's go ahead and write an equation. So in order for us to get the C value, the cost, what did we do to E? Because we want to be able to give a general rule that can be used for any number of energy use. So remember, the cost, we simply calculated those by multiplying 0.058 by the energy, the number of kilowatt hours, they used. So equation will be simply that, okay? I just wrote them right next to each other. That means we're multiplying them, okay? So this is fine. Now, let's look at some of the little more complicated cases where we're going to have something called a Y-intercept or it's not going to start at 0, 0. So 7, 8, and 9 are like that. And I think I'm going to have number 8 and number 9 graphed. But let's start with number 7 first. Very similar to the gas problem we just did. The distance you drive is proportional to the amount of gas used. Now I'm going to highlight this part. Driving 140 miles uses 5 gallons of gas. Now let me see. Is this the same thing as the one above? 140 miles, 5. No, it's slightly different. This one gets a better gas mileage. I do want to find that gas mileage first. So 140 miles using 5 gallons. So if I have 1 gallon, how many miles can I drive? So divide 140 by 5. You will get 28. Oopsie. So the 28 miles per gallon is really called your, what do you call this? This is your slope. Because the idea is every 1 gallon I have, I get to drive 24 extra miles, okay? So let's try to fill out this table. But before we go there, I want you to read one more sentence that we have under here. Assume you have already driven 100 miles. Now, if you get questions with something like that, we're not starting at 0. Even if you have 0 gallons, guess what? We already have driven 100 miles. So what you're going to say is our starting point is actually at 100 miles, okay? So we got 0, 100, okay? Now, next one, if you have 5 gallons, we can drive, well, for every gallon, we know we can drive 28 miles, right? So do that. But here's the thing. You're going to do 5 times 28. But remember that one distance that we already covered. So what you're going to do is you're going to multiply 5 times 28. But remember to add to the 100 because that, 5 times 28 will give us the extra number of miles that we will be able to go plus that 100-mile distance. So try that, 5 times 28, and then add 100 to that. You will get 240 miles, okay? Now let's try the other one, the second one. If you have 10 gallons, well, having 10 gallons means that I can go over 10 times 28 miles. But we started from that 100-mile point, so I'm going to add 100 to that, okay? So it's not simply just multiplying this time. 10 times 28, I get to drive 280 miles extra, but from 100 miles. So if you add 100 to 280, you will get 380, okay? All right, let's do the last one. 15 gallons, I will be able to go 28. And if you're wondering why 28, remember that's that slope that we found by, I'm going to ask you to find that miles per gallon to make these problems go easy. If you do that, let's see. 15 times 28 is 420, but don't forget to add the 100. So if you have 15 gallons, you will be able to cover a 520-mile distance in total. So if you notice, let's take a look at what's going on here. Because even though we started at a 100-mile point, this maybe it's not a good idea to look at the difference because they're not really going up by 1. They are going up by 5. But, at least they're going up by the same amount, 5. Notice from there to there, from here to there, I'm going up. This is adding 140, right? And then from here to there, I am adding another 140. See, this is proportional. This is staying exactly the same. So, but they're going up by 5. So if you divide this 140 by 5, guess what that is equal to? It's 28. So, just because you started at a different point doesn't mean this is not going to be proportional. It's going to be proportional, but the numbers will be a little more challenging to figure out. So hopefully this example will help you on your homework. But now let's write the equation. The equation should give us the distance, D, given G as our input. So just look at the way that we found these answers. remember, distance is equal to, what did we first do to the g? We multiply that g by 28, right? So you will do 28 times g, but that wasn't it. What else did we do? We added, what number? 100. So the equation this time actually has a y-intercept of 100. Because when g is 0, imagine when g is 0, if we plug in g equals 0, 28 times 0 will give you 0. And if you add 100, you will still get 100. So that's why number 7 was a little bit different. But, you know, I'm sure you're going to see very similar problems. So please get some practice on My Math Lab, okay? All right, let's try the last 2 examples. This lesson will be a little bit shorter than 4.4. Well, because it is the first section of chapter 5. All right, the cost of an airline ticket is proportional to the distance traveled at a rate. Now, I love these type of problems where they just give us the rate. Oh, hold on. It's not just 36. They said 36 per, okay, let me write this down. $36 per 150 miles flown. Now, what I'm going to do is I'm going to simplify that rate by dividing 36 by 36 divided by 150. 36 divided by 150 is 0. Now, let's write down the unit very carefully, okay? Because we want to be able to talk about that unit. What we're going to get is 24 cents, $0.24 per mile. Okay, so and what we just found, this will be our slope. This is the rate of change. This is going to be the slope. So every how should we talk about this? Every mile that we travel will cost us 24 cents on this airline ticket. Hold on just 1 second. My dogs are snoring so loudly. Go sleep somewhere else. Go. Alrighty. Let's fill in the table for the total cost. Oops. Look at me being careless because there is a second part, isn't there? It says assume that there is a base charge. Oh, the base charge of $25. So even though you travel 0 miles, it's funny because we still have to pay how much? We still have to pay $25. So for 0, do put 25, okay? All right, now the second part will be very similar to the example that we did for the driving miles. So let's do this together. So distance, 150 miles will cost us 150 times $0.24. But remember, we need to add the base charge of $25. So let me go ahead and use my calculator to figure that out. 150 times 0.24, and then if you add 25, you will get $61. Oopsies. You will get charged, oh my goodness, $61. Next one, let's multiply the 300 by what number? The 0.24. And then don't forget to add the base charge of $25. Because you'll notice it's not simply going to be 61 times 2. I know 150 times 2 is 300. But when you have those base charges or a y-intercept that's anything other than 0, 0, then you will, that simple rule will just not work. It's 300 times 0.24. And then if you add 25, you will get $97. That's not that bad at all. All right, next one. If you multiply 450 times 0.24, but don't forget to add the base charge of $25. Let's do that. 450 times 0.24. And then you add 25. You will get $133. So we are done filling out this table. Now, but what if we get some random distance D? Well, you still have to do the same rule, right? You multiply that by 0.24. And then you add 25. That's going to be your cost. Why did I write that? Because they're going to ask us for it. They're going to ask us to represent the relationship between the cost C and the distance flown D with an equation. So we got the equation down here. Let's just write this down with C equals D times 0.24. Let me write that as 0.24 times D, 0.24D. And then don't forget to add that base charge of 25. And that is your, y-intercept if you graph it. Let's try to graph this one. We never graphed anything yet. All right, graph the equation that represents the relationship between the cost C and the distance flown. Now, I want you to label your axis, though. Now, the x-axis, the horizontal axis will be distance, miles. So do write down this is distance in miles. And then the y-axis, we'll call it cost. Whoopsies. What's that? Oh, no, I messed up something. Oh, okay, now I'm fine now. Cost in dollars. Okay? I have how many points? Let me see. How I got 1, 2, 3, 4 points. Now look at the horizontal axis. The horizontal axis, I'm going from 0 to 450. 0 to 450. Let me write this down because I don't want to keep on scrolling up and down. I need 0, 25, 150, 61, 397, and 450, 133. So I just copied this table down here so that I can just focus on, I don't want to, keep on scrolling up and down. So look at the horizontal axis that needs to be starting, well, it always has to start at 0. And then it's going to go all the way up to 400. So I may just go 450. So let me just do this. I'm going to do this is 100. This is 200. This is 300, 400, and 500. So that I cover all the numbers on my distance, 0, 150, 300, and 450. Let's do the cost. Now it goes up from 0 all the way. I just need up to 133. So 133. What can I go up by? I don't want to go up by 10. Why not? Let's go up by 10. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. I need one more, 140. That's it. That looks good. Okay, let's plot these points. I need 0, 25. 0, 25 will be approximately right here in between 30 and, let me use a pen to plot these points. 0 and 25, so that's my first point. Next one will be 150. 150, this will be my 150, all the way up to 61, so slightly over 60, I'll say. So approximately over here. Next point will be 300, so at 300, I'm going to go up to 97, so slightly below 100 point. And then last point, 450. So here's my 450. And that will be up at 133. 133, probably just in between like 130. So it's not exactly like accurate. But I got 4 points plotted. And then you notice how these 4 points are going to be on a straight line together. So this is perfect. So this function will keep on going. It's going to go up to the right. But we cannot have negative distance miles, so the domain will just be from anywhere from 0 all the way up to however many miles they allow us to fly. Okay, so that's what we will do, and I think on your homework you will just have to choose from the given graph instead of actually graphing one yourself. Let's try the last one together, very last one, and that will be it for today. So this one will be a little bit shorter. Because I remember the 4.4 lesson, it took me some time to record all those lessons. But all right, let's finish this. Your monthly electric bill is proportional to the number of kilowatt hours of energy used at a rate of, now copy down or highlight that rate, 6.6 cents per kilowatt. Now, what I'm going to do is I'm going to divide that 6.6 by 100. Why am I doing that? Because I'm converting that into a dollar amount. That's going to be $0.066 per every kilowatt hour you're using. So guess what we just found? We just found the slope, or it's called rate of change. Okay, so we found that, and they gave you that the monthly base charge is $22.50. So what you will need to put down is that if you use 0 energy, you still need to pay $22.50. And this is probably more like it in real life, right? We still have to pay something. Okay, now let's go ahead and use our slope to find the energy bills. So this one right here, we will do 400 times 0.066, but is that it? No, we have to add the base charge of $22.50, right? So getting my calculator, I'm gonna do 400 times 0.066 and then add $22.50. The electric bill for this amount will be $48.90. Let's try these two. For this one, energy used is 800, but everything else will stay the same. You still multiply by that same rate, and you still add that same base amount of $22.50. Okay, 800 times 0.066 plus 22.50. I got 75.3, guys. There is a maybe if I'm typing something in my calculator too fast, and if you don't get the same answer that I get, there is a possibility that I make mistake, right? So if you see something wrong, just shoot me a quick email so that I can address that to everybody, okay? Last one, 1,200 times 0.066, and then add the base charge of $22.50. So this is just the rule that we're using. Typing this into my calculator. If I add $22.50, I got $101.70. So, well, after seeing about 3 of these, I think you will be able to figure out the rule, right? What if we use just the regular E, letter E for the energy, and then C for the cost to write a general equation? That will be E times, right? E times 0.066, E plus 22.50, and that is going to give us the cost. So, we wrote the equation already. Let's write this down here. Represent the relationship between cost. The cost is equal to, you first multiply this by the number 0.066. You first multiply the energy used by that decimal, and then we simply added the base charge of $22.50. So that's our equation, and that's what we're going to try to graph down and see, okay? So label your axis for me. Label your axis. Energy down here on the horizontal. And that was kilowatt hours. And then here was just the cost in dollars. And if I copy down my energy and cost function, I think it was 0 equal $22.50. And of course, I forgot the rest. All right, let me go ahead and copy down the rest. 400, 800, 1,200. And these values were 48.90, 75.30, and then lastly 101.70. So I'm going to go ahead and graph these. And our graph will never really be like super accurate, but I'm just going to sketch this. So always start your axis from 0. And then I decided to just go up by 400. Why not? I'm going to go up by 400. This is 400. 400 plus 400 is 800. 800 plus 400 is 1,200. I'm not going to need the next one, but the next one will be 1,600, right? All right. Now, let's go up on the cost by, I think I'm just going to go up by $25, okay? So, I'm going to go up by, this is my $25. This is my $50. This is my $70. And then this is my $100. All righty. Let's plot 0, 22.50. 0, 22.50, approximately over here. I'll just make my dot really big so that it covers that point. All right, next one, 400, 48.90. So slightly below 50. I'll plot a point right here. Just make it a little fat. All right, that looks good. All right, 875.70. So I'm going to go up above the 70 a little bit, approximately over there somewhere. And then 1,200, that's going to be above 100, $101.70. So maybe like around here. Looks good. It really shouldn't be a curve or anything. It does look to me like a perfect straight line. So we graphed it The equation is cost equals 0.066 energy plus 22.50. We'll do more of graphing on Excel on Unit 5. Your Excel homework will involve graphing lines and writing equations and like labeling your line with the equation that you used. Think different things, but you do only have one Excel homework this week, and that is on just exploring 5 different linear functions. So the resources for that homework is all posted on Canvas, and that will be it for really this week. Many of you have extension on Project 1 gradebook, so hopefully I get more submissions this Sunday, but about more than half of you are done with that part. So this week, well, maybe I should just go over the agenda before I stop this video. So week 11, I'm going to update this with new video link that I just recorded with you now. 5.4, my Math Lab homework 4.4, my Math Lab homework 5.1, Excel homework 5.1, and quiz 4. So these 4 things are what's due this weekend, this Sunday. But I know many of us are kind of working with extended deadlines on assignments from the past couple weeks. So, if you have that, just let's try to catch up, because our class is only 16 weeks and we are already on week 11. So we should be talking about making up assignments and different things, because I want all of you to end up with like an A or B. And another thing, if you do want to get A, B, or, a letter grade instead of the pass or fail, please go to Canvas and read the announcement. I linked the president's message on Canvas so that you can read more about it. There is a way for you to get those letter grades instead of just pass or fail. Or whenever you have questions, you just have to email me. Make sure to complete your attendance quizzes for Monday and Wednesday. They're both on Canvas. I started using these Canvas quizzes more often. I like them because they automatically grade and put the grades on Canvas for me. So those 2 little short quizzes are also due this Wednesday, okay? Very short quizzes. All right, that's it.